be soil mechanics, for example, geotechnical engineering, geology, and also at the far end we have some experiments to do with water, fluids, for example. At the moment students are away on a field trip, and one of the field trips they go on is a geology field trip, which is in West Wales. We used to go to the Isle of Wight and so on, but this is one of the laboratories. You can probably see some of the experiments on the end here would be similar to the ones you do back home in Tallinn, is that right? Quite similar. You recognise the kits, yeah, same as you do. Any university, anywhere in the world, doing civil engineering, you walk into the laboratory and you have a bigger version of this or a smaller version of this. You have to have the fundamentals have to be tested, of course, the ground engineering and so on. We have modelled down some research work going on here. Next time you see the water approaching, this bit of information. This is a weir. We artificially increase the height of the river bed and other patches of water. As it approaches here, all of a sudden it comes across this obstruction. Look how much faster and how much shallower the water is after it's gone over that construction there. You can design a weir by using calculus. You can use calculus in order to know how high the weir needs to be in order to completely change the flow characteristics. We have a river near us here called the River Taff. It used to be the third biggest tidal river in the world. The second biggest tidal river in the world is here south of Cardiff in the Bristol Channel. The first one's in Canada. We had massive problems locally with flooding, and the water was going too slowly and was flooding all the time. So we put loads of these in the River Taff to try and improve the flow, or we go from being deeper, tranquil, subcritical flow, and after this thing, if you increase the bed of the river by a certain height, you have what we call rapid supercritical flow, much shallower, much faster, just by raising the bed itself. And the reverse of that's taking place over here. This is what we call a hydraulic jump. We take some reservoirs and spillways, see water going down the hill, we collect it. And what's happening here with momentum taking place? It's gone from being shallow and fast, all of a sudden, not abruptly, into being slow and deep again. The problem in Cardiff, unfortunately, was that loads of these weirs didn't do the job, so what we did in the end, we completely dammed the Cardiff River Taff and the barrage in place now. Cardiff Bay has a barrage going across there. My guess would be that part of your visit would go there. It's a fantastic civil engineering project. I was involved with some of the design of that, and not my own, massive teams of engineers. My role was a very, very small part. We were monitoring the effect that damming the river would have on the natural water course locally and people living there. As we have to make sure that water would travel away from where we were going to stop this river suddenly. This is one of the experiments that students use, normally in year 2 and year 3 in their hydraulics, water engineering. And we have 3 or 4 different water modules, part of our degree here. I'm involved in delivering some of those. And some of this experimental kit around here we use. These are the post-tension wheels that the students use.
Hi.
Hi.
Valmis?
Täiega valmis.
Allar, mida sina said teada söekaevandustest?
Näiteks seda, et kunagi kasutasin väga teist valikut. Kõik mehed ja naised töötasid seda, mehed töötasid päris söekaevanduses ja naised siis töötasid väljaspool, töötasid seda kõike muud tehastes. Ja meeste keskmine eluiga oli kuskil 20–24 aastat. Ja selleks ajaks olid neil juba lapsed, 3-4 last. Ja lapsed pidid hakkama kuskil 5–6 aastaselt söekaevanduses tööle. See oli rohkem selline traditsioon. Ja neil polnud väga sellist muud valikut, et kuhugi mujale minna. Sellisel ajal ei olnud lihtsalt see moes, et nii-öelda käid oma isa järgel.
Henri, on sul midagi lisada?
Annar siin päris palju rääkis juba, aga näiteks seda, et seda süsi kasutati Titanicu laevas.
Tris?
Näiteks see söekaevandus, kus me praegu oleme, see sulgeti 1986 ja üleüldiselt siis hakati siin sütt kaevandama 20. sajandi alguses. Oli väga populaarne tööstusharu ja siin siis enamus inimesed töötasid ka.
Joe, do you agree with everything they said?
Definitely, and I think their Estonian is fantastic. Well done.
Thank you.
no nii, Allar ja Henri, mis me just tegime, mis just juhtus?
Valisime mingi rongi, sõitsime õigele poole,
oma arust.
aga poole tee peal keeras rong hoopis teisele poole. Ja jõudsime kuskile, ei tea kuhu.
Nüüd tuleb õige rong.
Nüüd peaks vist õige rongi peale saama.
Jep, positiivne on see, et läks alla tunni.
Don't forget, in the exam condition, I'm not going to give you this type of graph paper. Not this time. The graph paper will be similar to this, but it will be on your answer sheet at the back. So if you open your answer sheet at the back, you will see the graph paper. So you can do your graph work at the back. Then, when I'm marking, I will check. I'll mark it here. Okay? So when you are doing the graph will be attached to the answer sheet at the back. Don't forget. It's not going to be loose like this. It's going to be with. The idea is to avoid it falling off. So it's attached to the, it's part of the answer sheet. Okay? So the first question is quite straightforward. So what you could do is, they want you to draw the stress and strain graph. So what you first of all do is that you know the specimen, you know the diameter. So since you know the diameter, the first thing, the diameter is equals to what? Diameter is equal to what? 6, is that not? 6 millimeter. And then radius will be diameter divided by 2. Because I gave you the formula.
There are 2,300 students as in daily and distance learning as well. Usually, or like the school journey is 4 years, and students get like a bachelor degree with this time. And there are 6 institutes: architecture, circular economy and technology, clothing and textile, civil engineering, logistics and technology.
Some different ingredients, and we tested them for 28 days, I guess. And after that, we tested how strong the concrete was. And what was interesting, we saw a test when you have a plastic tube when the water flows, and you can calculate a triangle inside it to increase the flow of the water and decrease the level of water. And I found that very interesting, and after the tour I asked Baxter maybe he can give me some notes and I can study more about it, and the next day in the lecture he brought me some notes.
So firstly, we got to know some teachers and ate our first Welsh cakes which were delicious. And after that, Richard gave us a tour of campus, and he told a lot about coal mining and the history of campus. And he told that he recruits people or students mostly from China.
Tere, mina olen Allar.
Mina olen Henri. Mina olen Chris.
Me oleme juba 5 päeva olnud siin South Walesi ülikoolis. Oleme tutvunud linnakuga, selle kultuuriga, mis siin on, erinevate inimestega, käinud loengutes ja vastame nüüd mõningatele küsimustele, mis teid huvitada võiks. Nii, Chris, mida sa oskad öelda meile õppekava ülesehituse, alusainete ja erialaainete kohta?
Põhimõtteliselt, kui siia kooli tullakse, siis 3 aastat käiakse koolis, omandatakse bakalaureuse kraad ja siis on võimalik ka siis omandada magister. Magister on 1 aasta, mitte nagu 2 aastat nagu Eestis. ja iga siis eriala peal on siis esimene aasta on siuksed nagu alusained, mida siis nagu kõik võtavad, siis järgmised 2 aastat spetsialiseerutakse oma erialale ja siis magistriõppes ehk siis lisaaasta, et seal siis minnakse nagu täiesti süvitsi oma erialasse.
Allar, selline küsimus sulle, et kuidas õpe käib, loengud ja praktilised tunnid, kas kohal käimine on kohustuslik ning kuidas on e-õppega lood?
õpe käib siin nii, et iga aasta on 6 erinevat ainet. Üks aine annab siin 20 ainepunkti, mis teeb välja 200 tundi tööd, aga erinevalt meist käib siin õpe niimoodi, et iga nädal toimuvad nii praktikumid kui ka teoreetiline õpe koos. Ja kohal käimine ei ole enamus ainetes kohustuslik või siis ka üldse mitte kõiges. Ja e-õppe võimalused on siin sellised, et mõnes auditooriumis lindistatakse üles ka reaalajas kõik sellega toimub, mis toimub nii-öelda tahvlil õppejõul ja õppejõud ise ja seda on võimalik vaadata terve semestri jooksul internetist järgi, nii palju kui sa tahad.
Henri, räägi meile, kui suur on siis University of South Walesi väljakukkumisprotsent?
University of South Walesi väljakukkumisprotsent on umbes 8–10%, ehk siis päris väike protsent võrreldes meie kooliga. Ja peamine põhjus, miks see protsent nii väike on see, et kuna siin koolis või Inglismaal üldse on õppemaks aastas 6000 naela, siis õpilased panevad varakult plaanid paika ja on oma valikutes kindlad.
Aga Henri, räägi, kas tudengid käivad kooli kõrvalt tööl ka ja kas töö võib hakata ka kooli segama?
Rääkisime ühe selle ülikooli tudengiga, kes rääkis, et ehitusinstituudil tudengitel on esmaspäevad ja kolmapäevad vabad päevad, nii et enamus tudengeid käivad nendel päevadel poole kohaga tööl, et ei hakka segama.
Chris, räägi meile, kas tööandjatel on piisavalt insenere või on neist puudus?
Inseneridest on alati puudus, aga eriti on siis tööandjatel vaja just neid insenere, kes on süvitsi spetsialiseerunud enda erialale. Näiteks siis ongi läbinud magistriõppe. Allar, räägi meile, kas, millal ja millele spetsialiseerutakse?
Spetsialiseerumisega on siin selline lugu, et 3 aastat õpitakse tegelikult 2 suunda korraga, mitte nagu meil on teedeehitus ja hooneteehitus, vaid siin on mõlemad koos. Ja spetsialiseerutakse alles siis kas magistris või tööle minnes.
Speaking for the civil engineering courses, yeah? First year BSc Civil Engineering, students do manual drafting, so pencil, scale rule, drawing board, sheet of paper. We learn how to draw, and then we do some basic 2D CAD in the first year. Second year, we do some more advanced 2D CAD, and then an introduction to BIM using Revit software, Autodesk Revit. Final year, at the moment, you don't have formal lectures or teaching on using BIM, but you are expected to work together in a group on a group design project, and if you can use BIM as part of that design project, then that's great. So at the moment, we don't have a great deal of emphasis on it, and there's a good reason for that. Our courses are directed by professional practice, so we have an industrial advisory board that's made up of members of industry, so directors of design firms, consultancies, government departments, contractors, that kind of thing. We meet with them a couple of times a year, and so far they have said, yes, it's good for graduates, civil engineering graduates, to know about BIM and to have some understanding of how it works, but they don't want that to be a core skill right now, because civil engineers will have technicians working for them, and you let the technicians do the BIM stuff. You just tell them what to do. That's what they've said so far. Now, I suspect that will change going forward. I suspect there'll be a less of a reliance upon CAD technicians, and engineers will be required to get more hands-on themselves, particularly with the use of BIM. Not just from a design point of view, but from a project management point of view and a cost control angle as well. So yeah, that's where we're at the moment. We have only introduced BIM as a formal part of the civil engineering course last year. So this is the second year we're running that element of the course. Who knows? Next year could be all change again.